Okay, here in this video, we want to find all these properties of this quadratic equation. So first off, let's talk about the y-intercept first. So the y-intercept is going to be when x equals 0. So I'm plugging in 0 for x, and I see every single term is going to drop off, and all that I'm left with is my negative 12. And remember, the c term, this is my standard form, the c is always going to be the y-intercept of whatever this quadratic will be. Next up, for the x-intercept, I want to set y equal to 0. That's when I'm going to cross my x-axis. So let's do that. Over here on the side, let's set 0 equal to 2x squared minus 5x minus 12. And so here I have a quadratic, and you could solve that any number of ways. I'm going to solve this one by factoring. So 0 is going to equal, let's say I can factor this. I've got a 2x and an x. And so let's say I think that's going to work out to be a negative 3 and a plus 4. Does that work out? Negative 3x and 8x. Yes, that does. Yeah, that works. Okay, so now I'm going to split my factors. And I get 2x minus 3 could equal 0, or x plus 4 could equal 0. So it looks like I have x is going to equal 3/2 over here, and x is going to equal negative 4. So that means that my two x-intercepts will be at 1.50 and negative 4, 0. That's the two of them. So right now, I'm kind of visualizing what's going on with this graph. It's always good to come up with some sort of a visual in your mind. And I know right now I have this 0, negative 12, y-intercept. I know I have a y-intercept here at 1.5 and here at 4. So I know that I have something that looks kind of like this. Let's just pretend that it goes through this root here. But something like this. I know that I'm going down to this point and I'm going up. As far as the concavity, I can already see that this, from my sketch, this is going to be concave up. But I also know that because my a value is positive, that's going to be a concave up graph. Vertex. To find the vertex of this thing, I'm going to need to use negative b over 2a. So let's do that down here. So x equals negative b over 2a. In this case, b is going to equal, I forget what it is, negative 5, and a is going to equal 2. So here we go. X equals negative b, that's a negative 5, over 2 times a, which is going to equal positive 5/4, or 1.25. That's the x value of my vertex. So right now I have a vertex of 1.25, comma, and then I'm going to plug in whatever my x is, or this x value, into both of these spots and evaluate my y. And I did that beforehand, so you don't have to watch me do that. And I came out with a negative 15.125. Okay, as far as the axis of symmetry, that's going to always go through the vertex. So that's going to be x equals, it's a vertical line going through the vertex, x equals 1.25. My domain, all of these quadratics are going to have an all real numbers domain, or I can think of it as from negative infinity to infinity. As far as my range goes, this is my range is going to be all of my y values from this bottom here all the way up, going up forever. So it looks like my low point is that negative 15.125, and going all the way up to infinity. Notice here I have a square bracket on the negative 15.125 because I actually have that point on my curve. It's going to equal negative 15.125, and it's going to go up forever to infinity. As far as whether or not this is a min or a max, this is a minimum. Right here is the min. It has no max because it goes up forever. You can't get on top of forever. When is this thing increasing? Well, remember, I'm thinking about my x values moving, I guess, left to right. Hopefully I did that right. And if I'm looking at the right side of this graph, I am increasing. So that point where I'm turning is at the vertex. So I'm increasing from 1.25 to infinity. And on the other side of this thing, I'm going to be decreasing from negative infinity until that vertex, 1.25. And finally, for the end behaviors, I guess I'm kind of hiding this graph a little bit here. Here's my graph. For the end behaviors, I'm going to put that in green. Uh-oh, stop scrolling, please. I'm going to put that in green, and I'm going to put it right over here. Now, the limit, as x goes to infinity, of my function, f of x. And as I go forever in the x direction, my y values are going up to infinity. So actually, the end behavior on both sides of this thing, as x goes to negative infinity, I'm also going towards positive infinity. They're all my properties of this quadratic.